Thanks for inviting me back to talk. I thought I'd start this talk with some nice graphs. This is global life expectancy from 1900 to very recently. As you can see, it's a nice line. It goes up to the right. The source for all of these graphs, by the way, is Our World in Data. Fantastic resource. I highly recommend it. Here's another one. It's a bit more messy, but the trend is down and to the right, which is what you want to see when you're looking at the percentage of children that don't make it to the age of 5. It's amazing that nearly everywhere in the world is below 10%, even if they still have a long way to go to reach Western levels. And another great chart. The number of people living in extreme poverty has fallen, and it's fallen even as the global population has risen. Again, looking from the 1800s to the modern day. This is healthcare expenditure, again, up and to the right, and it's from around the 1900 mark to fairly recently. It's a wonderful set of charts. And here's another one, also going up and to the right. Annual CO2 emissions, carbon dioxide emissions from the burning of fossil fuels for energy and indeed cement production. And another, CO2 concentration in parts per million, again, up and to the right. Globally, we've ridden the fossil fuel energy curve to greater life expectancy, lower child mortality, less poverty, greater health outcomes, and a larger population. But it comes at a cost. We've burned our way to success. And now the challenge is to level off the curve of CO2 in the atmosphere to stop it going up and to the right. And we've got to do that by flatlining our fossil fuel CO2 emissions, not just levelling them off, but dropping them. We've got to do that without sending all those nice curves of poverty and health and life expectancy and global population back to where they came. Last year, I mentioned that the IET had challenged itself to achieve net zero by 2030, and also that we didn't know how we were going to do this. Since then, we've taken a first go at calculating our CO2 emissions. And so we can look at the before times, also known as 2019, the time we worked from home, 2020 and 2021, and we can even have a go at predicting what our hybrid working might look like in 2022 and beyond. And the numbers are very interesting indeed. We've broken down our CO2 emissions as follows. We've got the IT technology estate, and here we're talking about Azure from Microsoft, AWS from Amazon, Rackspace and Server Choice, which are two data center suppliers that we happen to use. We've got our IT equipment, and here we're deeming that to be a laptop and a monitor per member of staff, because the other kit is either associated with the technology estate or indeed the building itself that we occupy in Stevenage. We have our commute emissions. We can look at pre-pandemic and future hybrid working, and our air travel emissions. We've also got our working from home emissions. And then we've got other supply emissions that are attributable to us. And finally, we've got our baseline core IET emissions attributable to the IT department. Essentially, that's the components of our offices in the UK and around the world that we need to account for. I'm about to show you the results of our calculations. Now, they're not complete. We've had to estimate in various places. And frankly, there's some key numbers that we don't have any data on. We're most certainly underestimating our total emissions, but I think that we've a pretty good handle on our direct CO2 emissions. And hopefully, these numbers are good enough to be useful. By that, I mean get us thinking about what to do next. So let's start with the technology estate. We can get very good Scope 1, 2 and 3 numbers from Microsoft, and I'll explain what those are a little bit later on. They have a superb tool for analysing Azure data and how the things in Azure are calculated in terms of their CO2 emissions. It's very, very good indeed. We've used that to act as a reckoner for our AWS spend, because when we asked AWS if they had something similar, the answer was no, but they are working on it. Our traditional data center numbers are basically the power consumption for the kit we have, so we're underestimating CO2 equivalent there. Our cloud estate is far bigger than our data center estate, yet the cloud emissions at fullscape are lower. But actually in the UK, with a good baseline power mix with a lot of renewable energy, the emissions actually are remarkably low. But it's very clear, go to the cloud if you want to minimise your carbon footprint. And also be choosy about which cloud provider you use. I've put the numbers here. 2019, 19 tonnes of CO2, 29 in 2020, and then a drop in 2021 and 2022 of 13.2 tonnes of CO2 equivalent. And most of that is actually us seeing the effects of Microsoft baking in their efforts to achieve net zero by 2030 themselves. Let's move on. So we don't have data on our embodied CO2 at this time, so our calculations are on the energy consumed for our IT equipment. Laptops and monitors are super efficient things these days, and again we benefit in the UK because of our power mix. There's lots of renewables in it. In terms of power, just under 3 tonnes of CO2 equivalent per year for all IET staff. But here's a thought. Do you buy a much higher spec laptop in order to maximise their lifespan and minimise the CO2 equivalent from repeated rounds of procurement of cheaper laptops? That's an interesting one. I think we need to have a good think about that. Seems everyone goes straight to the plane trips as a way of knocking down the carbon footprint. After all, there's plenty of articles out there on the subject of how bad planes are for the environment. Now, it's quite hard to figure out what the actual emissions are, as the airlines aren't keen on helping. So kudos to British Airways in this case. He got back to me with a link to an independent calculator for their flights. And although we don't just fly with British Airways, we've used those numbers as they're probably good enough in terms of the flights and the planes that are used for us to do a calculation. Basically, we fly to India, we fly to the USA, and we do that to visit our suppliers. We also will tack on a conference if the timing aligns correctly. In 2019, that was 27 tonnes of CO2 equivalent. We're predicting 30 tonnes of CO2 equivalent for 2022, assuming we can get back on the planes again. I don't think I really need to tell you about 2020 and 2021 because nobody really flew anywhere in those years at least. Working from home. So in the UK, that basically means winter heating. That's typically gas, as well as the power used for the laptops and the monitors we've given to the staff. Now, we benefit from a temperate climate, at least in the south, so we don't have cooling to account for. Of course, further up north, their heating costs are far higher. But we do have to account for winter lighting. So a shout out there for the LEDs, because 200 watts of power, which is what we've allocated in our calculations, is a lot of lighting. A laptop and a monitor consumes about 150 watts of power. And you plug all of that into a spreadsheet with heating days and lighting days and so on, and you get about 37 tonnes of CO2 equivalent used to work from home. Put another way, that's about 0.00279 tonnes of CO2 equivalent per person per day, or just a little over 2 3/4 kilograms of CO2. Commuting. We asked our IT staff to tell us what their round trip commute was in miles, and to use Google Maps to do that. We asked them to tell us what their mode of transport was, so car, train, bike or foot, and the fuel type and real-world MPG for any commuting vehicle used. And then we did the math. Now, for this set of data, we've actually got the embedded CO2 for the vehicles, and that's accounted for. So that's production and lifespan and recycling and junction. It's actually a very good CO2 calculator that we've got for this. And in total, our staff commute 6,079 kilometres per commute day. And yes, I did run that calculation more than once. To put that into perspective, that's travelling from our Stevenage office in the UK to Ann Arbor, Michigan, every single commute day. In 2019, that was 260 tonnes of CO2 equivalent, which makes me wonder what that was all about flying again. The other way of looking at this, of course, is to say that it's the distance to the centre of the Earth, and I'll leave it to you to decide whether flying to Ann Arbor and back every other day is better than going to the centre of the Earth or not. Nothing against anybody from Ann Arbor. I'm sure it's lovely. Our building emissions. We're refurbing our head office. It's going to be incredible. We've taken a 1980s building and gutted it. New windows, new super efficient heating. We've covered the atrium. That actually removes 4 external facing walls by doing that, thus dropping our emissions. There's some DC to DC power to see how that works. We've got solar panels on the roof, all kinds of stuff. We think that will drop the emissions from the old office by some 30%. And our 2022 prediction is for about 151 tonnes of CO2 equivalent to be attributable to the IT department. So, if you didn't know, CO2 emissions are categorised into scopes. Scope 1 is direct emissions from owned or controlled sources. Scope 2 are indirect emissions from generation of purchased energy. And Scope 3 are all indirect emissions in the value chain of the organisation. Now, this includes both upstream and downstream emissions. Upstream, that's you if you're a supplier. Downstream means customers. Supply chain numbers are the hardest to get. That's why really there's a gap in our calculations. But we do have a good number from Microsoft. And we've done our calculations here that I'm talking to you about right now. We're going to be asking you, if you're a supplier to us, to tell us how much of your carbon emissions are going to be attributable to us and what you're doing about those numbers. So we're looking for all of our suppliers to start doing calculations like the ones that I'm showing today. And the reason for that is simple, because the IET's goal is to be net zero by 2030, and we can only achieve that with you. And this is what the numbers look like when you add them all up. In 2019, we think the IT department of the IET emitted 572 tonnes of CO2 equivalent. That's because everybody was in the office basically all of the time. In 2020, it's 350 tonnes of CO2 equivalent because effectively everyone worked from home from about the middle of March onwards. In 2021, you can see a further drop down to 278 tonnes of CO2 equivalent. Almost everyone is working from home. 2022, we're thinking we're going to go back up to 345 tonnes of CO2 equivalent. And our prediction there is based on the idea that folk will be in the office approximately 2 days a week. Now, our productivity went up in 2020, and it went up again in 2021. We were quite shocked when these numbers popped out of the spreadsheets. It's hard to wrap your head around what a tonne of CO2 is all about, let alone 572 of them. Especially when on the overall scale of things, these are actually quite small numbers in terms of CO2 emissions, though one can extrapolate that the wider organisation emits much more, of course. So let's think about a tonne of CO2. It's equivalent to 2 super large hot air balloons. So what I want you to try and do now is imagine 1,144 of the things floating by in the sky every year. Off you go. I'll give you a moment. Here's another idea. Apparently, it's also equivalent to 125 cubic meters of Coca-Cola. One presumes that's the bubbles. So if anybody can visualize 125 cubic meters of Coke, you let me know about that. But also plants absorb CO2 and they use it to grow. So let's see if this works. Now, one tree absorbs 1 metric ton of carbon. But there's an important point. It takes 100 years to do that, i.e. when it's fully grown. So that's actually 10 kilograms of CO2 per tree per year. So to capture a tonne of CO2 emitted in a year, you need to plant 100 trees. Now, other numbers are available, but here we're talking about Great British trees and the Great British wood in Great Britain. Okay. Now, our IET 2022 emissions are predicted to be 345 tonnes of CO2, as I showed you earlier. So we would need to plant 34,500 trees to completely offset that. And the question now is, how big a bit of land do you need to plant all those trees? Now, if you look here at this slide and the small square at the bottom right, that's the IET head office in Stevenage, plus the car park, plus the road outside. And that's 11.5 hectares. And guess what? You need at least 11.5 hectares in order to grow 34,500 trees. And that's 11.5 hectares of tree planting per year if that's all we do. By the way, using trees as carbon sinks is actually rather a complicated thing to do. Now, short term, investing in serious, accredited, meaningful tree planting projects seems to be a good way of compensating for the burn that we do. But it's not a complete solution. Just the IT department ends up just having to acquire and then plant a very large chunk of Stevenage where we're based, if that's all we do. And that big square, that's just 8 years of our hybrid working CO2 emissions. If we extend it out to 2050, which is when the UK government says the nation as a whole will be at net zero, we need all of Stevenage. And that's just the IT department, not the rest of the IET. And by the way, these calculations rather suggest that the cost for a tonne of CO2 as a UK carbon credit might not be calculated correctly. Because when I looked that value up as part of this talk, I got a number of about £50 per tonne or thereabouts, which kind of suggests that you can buy land and trees to the size of that small square for a bit less than £18,000. And I've got news for you, that can't be done, not even in Stevenage. It was the commute numbers that really stood out for us. When you look at our CO2 emissions broken down as we have, it becomes very obvious that there's not much that we directly control. We can shift all of our estate to the cloud and we can bank the efforts from Microsoft and AWS to get us to net zero and move if we're not happy with what they're doing. But if we're going to use trees to properly offset, we need to pick the things we will apply that to very carefully indeed. This calculation on the slide here really stands out. If you don't burn stuff to get to work, our IT department alone could eliminate almost 100 tonnes from our CO2 emissions. And that's a build, run, recycle calculation, by the way, using those CO2 conversion factors from the UK government. Of course, it'll require all of our staff to go and buy or lease an electric car. But here's a thought. Will they have changed their cars in the next 8 years? Can we do something to move those who live nearer to Stevenage to something other than the car? It's a similar story when we look at the work from home data. In the UK, it's basically gas central heating, as I said earlier, and our calculations show that this is by far the largest component of the working from home emissions. What's our role as an employer in these areas? And of course, what's true for us is true for our suppliers. The numbers will be different and the split, the makeup will be different. So it'll be interesting to see how the proportions change. India, for example, has much lower per capita emissions than the UK, but it's also a lot larger and there's a lot more people there. A lot of its power comes from burning coal. So whilst the commute into Mumbai is largely by train and public transport, I believe, and that's good, it'll be interesting to see just how it all works out. But there we go. 2022 emissions for electric vehicles predicted to be 38 tonnes of CO2 equivalent versus 132 tonnes. And if you went to fully renewable power, you bring that number down even lower. 2021, that number shows us what's possible. Not every industry can work from home, but ours can. And we haven't even optimised for anything else. Our 2022 prediction shows us the challenge of hybrid working. Now, it's a massive improvement on 2019, but now we can measure the cost of being in the office in terms of CO2. And all I can say is, those meetings had better be worth it. We can't just plant our way out of trouble, but doing it properly and at scale will certainly buy us time to achieve other transformations. The very first talk I gave at this event, I spoke about disruption, about true disruptive events. The pandemic is one such event. It's shown us the fragility in our hyper-efficient just-in-time supply chains. It's shown us global inequality again. But it's also highlighted which industries or the parts thereof can not only exist but thrive when completely upturned. In February of 2020, nobody would have entertained the idea that working from home at scale was a feasible thing. Sure, some folks could do it, some businesses even. But it turns out that a lot of people can. And this is particularly true for those of us in the ephemeral goods business. We turn electrons and photons into money. We don't make widgets. Why burn stuff to do that? Why then do the things that the Industrial Revolution initiated and Henry Ford and others built upon? Why insist that white-collar technology jobs are the same thing as blue-collar industrial ones? Turns out that if your job involves turning on a laptop, then you know what? You can do that job from just about anywhere in the world. Just remember to press the space bar to unmute. Now, like all disruptions, there will be, and indeed there is, quite some turbulence. And if your capital portfolio involves the asset class known as the commercial building in New York, London, Singapore, Tokyo, and elsewhere, then you probably would really like the workers to come back to their cubicles. After all, that fancy yacht won't fuel itself. The technology to enable work from home at scale didn't really exist a decade ago, but it does now. We just didn't spot it. Some folks did, of course, but it took a virus to get the rest of us to understand. And yes, we are social creatures. And yes, we do need to be together. But at 6,000 kilometres a day and 1.5 tonnes of CO2 equivalent, it's only right that we should ask a hard question about the value of the time together, because that bill will come due and it won't be evenly distributed. I was reading the other day that some initial research indicates that women have found it easier to be heard in virtual meetings than in the real, less being talked over by men, and easier to make points. The equality of a rectangle on a monitor. A long-standing partnership with our friends in Mumbai needs an update, because a bunch of them went home to family all over India, and actually we didn't notice. They're our friends in India now. Yes, there will be negatives, and I don't mean to belittle them. But on the other hand, if our kids can live somewhere not determined by the effective transport radius of a concrete brick and glass box in a postcode determined by obsolete clustering algorithms, then just maybe they might be a bit better off. They'll need to be, because the burdens of the global climate emergency will fall on them. We have a lot of work to do to get our bit of the IET's carbon footprint emissions down to net zero. The EV commute calculation is a striking one. That's an enormous chunk of our emissions, even in a hybrid working world. In fact, it would take us below our 2021 number. Similarly, moving from gas and standard UK electricity to renewable home power and heating, maybe using the power from our cars when they're just sat there, would bring more savings. But that's a collective action problem, as is working with our suppliers to drive down on those carbon costs. We could leave it to our governments. We could go to work. There's a ton of technology already out there just waiting to be applied to flatlining our emissions. Solar just keeps getting cheaper, outperforming all the cost performance prediction curves, even when they're recalculated. It's the same with batteries. Cost per kilowatt hour in 2010 was $1,160 in 2020 equivalent. In 2020, it was $137. When it hits $100 a kilowatt hour, an electric car will be cheaper to manufacture than an internal combustion engine is to produce. In the UK, there were new motor technologies that are more efficient and easier to manufacture and recycle, and they're already with us. They don't have any of the problematic materials in them. They just need car manufacturers to go use them. And there's innovation happening across residential and commercial heating for wherever you are in the world. But this will be the most radical revolution in how we power the world since the Industrial Revolution kicked it all off. Net zero by 2030. I hope to see you there. Thanks very much indeed. And I think now, perhaps, we've got some time for some questions. All right. Cool. So I've got one question, I think, in the comments panel. So if people want to put their hands up or alternately start typing away frantically in the chat box, I'll see what I could do to answer your questions. There was one right up at the start. Do these numbers take into account CO2 equivalent for working from home specific to the work component? Yes, they do. So for the 2021 and 2022 numbers, we split that out. 2021 was pretty easy because nearly everybody in IT is working from home. We have a couple of guys in infrastructure that are heading into the office to provide some support, but it's very little in the overall scheme of things, and they also happen to live very locally. In 2022, our prediction is using that commute information that we've got and working on the principle that actually everybody will be in the office for an average of 2 days per week and working from home the rest of the time. The other thing, certainly in the UK, the working from home costs are loaded effectively for autumn, winter and early spring. But we've averaged those emissions out over an entire working year. It just seemed the easiest thing to do, and you get to the same number at the end anyway. It's just the curve, the distribution curve that happens to change. So we've got another one. Other departments within the IET done such benchmarking, and is the IET collaborating with other publishers to share work with such data? So yeah, the organisation as a whole is committing to work to net zero by 2030. We're very pleased to say we're working with investors in the environment. Just got our bronze badge from them, so that's very nice. So we are starting to collect data across the piece. We wanted to have a good look ourselves because, being nerds, we really like some really cold hard numbers, and so that's why we were quite happy to sit there and pound away at a load of spreadsheets. So we've done that, and in terms of collaborating with other publishers, well, there you go. I'm talking about this now. I certainly think there is a great deal of value in a very open conversation amongst all like-minded organisations who might want to understand what's going on, what their world looks like, and share information. All the rest of it. I mean, there are some obvious thoughts in terms of conversations with suppliers, for example, and there are also. I personally, I realise, we're actually quite lucky in the UK, right? We get a lot of wind power, and that's not just from our politicians. So I had to go there. So we're very blessed in terms of our renewable mix. Earlier on in the chat, today's renewable mix, 2/3 of the power that the UK is using today is from renewables. So our carbon footprint for power is actually really quite low in terms of other parts of the world, right? I believe India, for example, I think you're very highly dependent on coal. So you could be far more efficient, say, in terms of commute and all of those kinds of things, but the source of your power is a lot dirtier in terms of CO2 emissions. So that's a greater challenge. And I think those challenges will vary in other parts of the world. Right. Are we going to be encouraging staff to use electric cars with incentives? That's a very good question. I don't know. What I do know is that there are some schemes out there. There is a salary sacrifice scheme out there that I'm aware of for people. An interesting one, and I'm just speaking very personally here, is I'm aware of the fact that, for example, as an organisation, we offer interest-free loans for people that commute by train. So we could do that. I don't know whether one can offer an interest-free loan
for a member of staff to help them if they are choosing to do an electric vehicle. But there's, cycle to work schemes and stuff like that. So as an overall point, it feels like an area that ought to be explored. What else have we got? Have we signed up for the UN SDG Publishers Compact? I honestly don't know the answer to that. We've signed up for a bunch of stuff. Whether we've signed up for the Publisher Compact, I'm not entirely sure, to be honest with you. What else have we got? Are we seeing suppliers come to you proactively with their net zero efforts? Not so far. So I'll tell you an interesting thing. The other thing we did, and I didn't talk about it particularly in this talk because the data's a lot hazier. We have a lot of suppliers. Depending on how you cut it, we're over somewhere between 60 and 90 suppliers. And before you go, surely you must know the number of suppliers. We have multiple products from similar suppliers, so that's what makes that number a little bit fuzzy. And we started to do an exercise to try and understand what commitments those suppliers were making. And this is anecdotal, but it's quite hard to find out information that people are putting out there. Dare I say, a lot of it is awfully like greenwashing. And so again, I think there needs to be some encouragement there. We had a fascinating conversation actually with AWS. We have really good engagement with AWS, actually. It's a real joy. And we sort of sat them down and went, look, we've got this wonderful tool from Azure, because they know that we're with Azure as well. And they said, look, gives us an actual number. And they said, yes, well, you're in Ireland, so it's carbon neutral. And we were like, yeah, so how much CO2 do you use it? And they were like, yeah, okay, we can't get you that answer right now, but they are working on it. So they've actually seen what Microsoft have done and are trying to come up with a tool themselves. If you want to get to the wonderful world of trying to work out AWS carbon emissions, there are, I think on Medium, someone went to a lot of trouble to try and figure it out. And I believe they have a spreadsheet at the end of it, which if you're an AWS user, you may or may not wish to try and use to plug in your own AWS environment to see what numbers it gives you. But it does get into quite down the rabbit hole stuff when you're trying to work this out. So good question. AWS versus Azure, are you seeing any difference in CO2? We will find out. We made an assumption. And we made an assumption that AWS was roughly equivalent to Azure for us. And that's basically because of the locations that we are primarily based. So for Azure, we're based basically in the UK. And for AWS, we're based in Ireland. And both have a pretty decent renewables mix. So that's why it is an assumption and we do need to get a proper number. But essentially our calculation was relative size of estate as a multiplier for the Microsoft number. The Microsoft number is really good. I'm not really in a position to share the details of what it tells you because it tells you an awful lot of detail. So you can go right down. We can actually figure out CO2 emissions per product if we so wish. And we're taking a look at some of those areas. What we do see is the numbers are varied. A couple of years ago, it was 12 tons of CO2 equivalent for a smaller estate. So we think what we are seeing there is the results of Microsoft's personal commitments that they have made, which is to be applauded, and they need to be held to them, but they are to be applauded in working very, very hard to bring down their carbon footprint. What kind of support are we getting from local central government for net zero, if any? I don't think we're getting anything actually at this moment in time now. Whether that's because we're not asking for it, I don't know. It's an interesting one. Hopefully, if you've seen these numbers, I don't know what you might have thought. Actually, I'd be interested in what you all would have thought at the start of what the numbers would be. I did not have our commute number as being the biggest number. It just shows that you don't really think about these things. MarkLogic platforms compare with others. All right, and right, is that Mark? I'm going to punt that MarkLogic question. Are you asking in terms of CO2 equivalent? Is that the nature of the question? Yeah, okay. So I would call out one thing. The one thing that becomes very immediately apparent from our direct data is that going to the cloud immediately, if these guys are telling the truth, brings you massive benefits in terms of lowering your CO2 emissions. Our direct attributable to us kit is higher for less actual stuff on them than our not insignificant cloud estate, certainly not by amount of money spent on it anyway. And that's a really thought-provoking thing. So it does show you that sense of scale and the ability to apportion that across multiple customers really brings some scale-up benefits. What am I hoping to see come out of COP26? Well, what I would like some proper commitments to say that we're going to deal with this properly. What else would I say? If you look at it from the point of view, my point about starting with the curves, right, was we've got to re-engineer our planet to not burn stuff, right? And we've got to do that without killing people, which means still being able to use the technology, right? And that's why I personally think that the sort of politics of penitence aren't particularly useful. So I think what we need to start having the conversation is about re-engineering the incentives. There are a huge number of incentives and subsidies, and those subsidies currently apply to fossil fuel companies, right? Now, you've got to do an escalator there. You've got to down ramp those subsidies, right? And you've got to start giving subsidies to other industries that are doing the things that you want to do. It's absolutely bizarre, right, that you could get subsidies if you're a company doing in the fossil fuel business, right? But if you're a company doing solar, nothing for you. If you're doing innovative, renewable or low carbon heating and power technologies, no subsidies for you. That needs to change. So I would hope that COP26 comes out with something in the arena of rejigging where state incentives are applied. That would be really, really useful. Okay, how are we doing for time, by the way? We're okay, we've got a couple more. So we've got any more questions? Does the initiative have an owner? How is it structured? So there's a group. I'm on that group as it happens. So we do have a net zero governance group. The owner of that is our chief financial officer, and he reports into the CEO. So we're taking it pretty seriously. And so I could say this, it's not a throwaway comment, right? Net zero for us by 2030 is in our 2030 strategy. It's been reported to our council and our board of trustees. So it is a key thing that we have committed to very openly that we're going to try and do as seriously as we possibly can. And yeah, we are taking it very seriously indeed. The work that has been done as part of the refurb of the building, for example, technologies have been picked that bluntly are more expensive, but they're more efficient. I think we have a very, very innovative, certainly it was very expensive, heating and cooling system, for example, air source heat exchanger and on all sorts of other bits and pieces, and it's intelligent. And the money's been invested in that. And I think that's an interesting story in order to get a sense for how one takes an old building and does the money to refurbish it and hopefully have it work effectively for another 30, 40 years before we have to go and do it again. Get back to you on that one, Yadi. Yeah, that's that one. Is there one last question? How are we doing? 43. One more question from anybody? Right. Well, in that case, you know what? For all the virtuous stuff, I do kind of wish one like this, well, one I wish I was there, to be honest with you, but we'll worry about that later on. I do wish I was actually in a room with all of you, because it would be good to see you. And it would also be good to see how we could extend this conversation out and see where we could go with it going forwards. But I hope you found my talk useful and informative, and you know where I am on Twitter and other places if any of you want to get hold of me. So thanks very much for your time, and I hope it's a great rest of the conference. I shall be around for some of it for certain. Yes, Jonathan, before I go, yeah, I think we will be looking at how our procurement process operates in the years to come, for sure. Cheerio, everybody.